The next sentiment analysis that we performed was using a multinomial naive Bayes classifier. This model takes the preprocessed text as input and tokenizes the string into a list of words. This is usually done on whitespace by default. Next, we compute the hash term frequency, which is the step in which the preprocessing makes the biggest difference. Our model would not be very reliable if the words and, of, and I were given the highest frequency count for both bullish and bearish tweets. Lastly, we use the inverse document frequency to give more weight to words occurring less frequently in the dataset. The actual sentiment score produced by the naive Bayes classifier is actually a conditional probability of the tweet belonging to each category, bullish or bearish. As this chart shows, a tweet that has a 95% probability of belonging to the bullish category would have a sentiment of 0.95. Bearish tweets follow a similar pattern but trend toward -1. The interesting case is when the model has difficulty categorizing the tweet as either bullish or bearish. In this case, we offset the probability positive or negative in the direction of the higher probability but centered around 0, indicating that the tweet was close to neutral. The model was trained on 2 months of historical data accounting for approximately 30,000 labeled bearish and bullish tweets. The test set accuracy was about 75%, with almost 90% accuracy in correctly classifying bullish tweets. The model tended to predict bullish more often because there was a 2-to-1 ratio of bullish to bearish tweets in the dataset that was collected. The daily aggregate sentiment produced by the naive Bayes classifier seems to have limited correlation to the daily stock return, showing that in some cases it can follow the same trend, but overall it does not appear to have much predictive power. On the other hand, we chose to compare the intraday stock price for Apple on March 28th, which happened to be the highest tweet traffic day in our dataset, with the aggregate sentiment score produced by the naive Bayes model, and it very closely correlated to the intraday stock price. What is difficult to tell from this plot, though, is whether the social sentiment was a leading or lagging indicator of price change.
We also performed a bit of regression analysis to understand the relationship between various parameters, like is there a relationship between trade volume versus tweet volume? Stretching it further, can we explain changes in the underlying stock prices using sentiment score, or either using sentiment score or tweet volume? So we first calculated a simple correlation coefficient for many combinations, which is shown here in the form of a table. Interestingly, for Tesla stock, we found that there is a very high association or correlation between tweet volume and the trade volume. Likewise, tweet volume is highly associated with sentiment score, reflecting either bullish or bearish underlying nature. This slide shows a simple linear regression between sentiment scores and stock prices. The sentiment score in this particular regression, we used the scores calculated from financial dictionary model. As you can see, there is a poor fit in case of Apple stock, which basically means there is no causal relationship between sentiment scores and stock price changes. We also show the tensor board loss function here during the training of the model, which converged after 700 or 800 times of training. Continuing further, we also did the regression analysis using sentiment scores calculated from other models. The second one being we used Harvard Dictionary model, and the third one the naive Bayes model. So we plugged the sentiment scores from derived from each of these models and tried to see if there is a relationship with the stock price changes on a day-to-day basis. Like in the previous slide, we did not find any particularly interesting pattern except for Tesla. As you can see in the last slide here, the right plot. When we plotted when we try to fit in a cubic regression, it kind of fit in relatively well when compared to a linear regression, and that's what you're seeing here on the right side of the slide, with a cubic regression fitting relatively better. We have come to the conclusion part of this presentation. We will briefly go over the benefits of the system that we built here. We'll also talk about challenges and limitations of the system. At high level, our system is capable of gauging the social sentiment of tweets against the changes in the stock prices. Our system provides a simple methodology to calculate or predict aggregate daily sentiment scores for a given stock by processing all of its raw stocks. And we did this by building multiple models, as explained in the previous sections. To summarize on the three models, what we noticed was Financial Dictionary performed much better when compared to the Harvard Dictionary, partly because of better vocabulary suiting the domain that we picked, the stock market tweet analysis here. And the naive Bayes model also performed pretty well, partly because the training was done on the pre-processed tweets, which took care of filtering a lot of the noise through the simple NLTK techniques like lemmatization, stop word filterings, and things like that. In terms of technology, we built it using Python, which is simple, and its easiness in terms of integration with various technologies like web downloads, text analysis, streaming, and the machine learning packages. The system, what we built, also has the capability to run in a concurrent mode using the Spark package, where we could do this processing of the raw tweets in parallel for different stocks. In terms of challenges, there's like a data download part had a limitation of 200 requests per hour. That's partly from stock tweets API restriction, and we had to provide some dynamic behavior by having batch jobs run overnight with intermittent sleeps. And more important, when we are talking about tweets, there is often the noise part is much more due to the unstructured or informal language. What we realized is that we probably need more sophisticated NLTK techniques to derive the real intention of the tweet. All of the project documentation in terms of data, coding, logs, documents, everything is available as a GitHub project, as shown here in the URL. Finally, a bit of references from the research what we have done for this project is shown here. Overall, it was a great experience working with the TAs and professor on this big data analytics course. We truly enjoyed and learned quite a bit of things. Thank you.